Hello everyone. My name is Malik Arslan Nisar, and this is the week 9 of the tutorial sessions for the course Numerical Linear Algebra. So, today we'll be solving some sample problems which would be helpful for you in solving the assignments. So, how many of you have gone through the week 9 lectures and attempted the assignment as well? Kavita? Okay, so you have tried the assignment?
Yes, ma'am.
Okay. So, were you able to solve the question because today the live session was shifted by 2 days? Okay. Anyways, let's um get started. Is my screen visible?
Yes, ma'am. What happened? Yes, now visible.
Okay. So, would you like to summarize what you have gone through the week? Any?
Singular value decomposition.
Okay. And more or less related to that only.
Yes, ma'am.
Okay. So, I'm solving the previous year assignment, like questions from that. So I hope they would be helpful. So let's try with this simple question. What are the singular values of a is equal to 0, 1, 2? Please try to find what are the singular values of a. Can we do this? We know that singular values of a are nothing but eigenvalues of a transpose a, right? So that would be what? A transpose into a, sorry, this is A transpose. So when we multiply this, we get 0, 2 into 2, 4, 4, 4 and 5, right? So quickly tell me what are the eigenvalues you're getting for this matrix A transpose A. Everyone? It will be 4 minus lambda, 4, 4 and 5 minus lambda, and the determinant will be equal to 0. 4 minus lambda into 5 minus lambda minus 16 is equal to 0. It would be 20 plus lambda square minus 5 lambda minus 4 lambda, 9 lambda minus 16 is equal to 0. And it would be equal to lambda square minus 9 lambda plus 4 is equal to 0. So lambda will be what? 9 plus minus under root of b square minus 4ac. So that is 81 minus 16 divided by 2. It will be 9 plus minus under root of 81 minus 16 is 65 upon 2. Now these are the eigenvalues of A transpose A, and we know that singular values or sigma square of A is equal to lambda of A transpose A, right? And from here we can write that singular values is equal to under root of lambdas of A transpose A. So it will be nothing but under root of 9 plus minus under root of 65 upon under root of 2. So this was a simple problem. I hope you would have gotten it, everyone. Okay. Should we move to the next question?
Yes, ma'am.
Okay. So okay. So here we have one question that applying Hager's algorithm, we have to estimate the condition number of a matrix A. Okay. So you would have studied this during the week. Now the given matrix here is A is equal to 19, 2, 8, minus 1, 2, 21, 10, minus 3, 8, 10, 20, 14, 1, minus 3, 14 and 19. Okay. So this is a given matrix and we have to get an estimate of the condition number K1 of A for the given matrix. So how will we solve this? Anyone?
Same question.
Okay, same question is there in your assignment.
The assignment also discussed in the lecture.
Okay, the same question is discussed in the lecture.
Yes. Yes, ma'am.
Okay, so
Same question.
not even the value change.
Yes.
Okay, fine. So should we move further, or maybe I can quickly discuss it, because if someone hasn't gotten the time to like watch the lecture, he would get the answer for the assignment. Okay, so we'll quickly go through the solution. We know that for estimating this, we first do what? When we have to estimate the condition number of a matrix, we form a vector B. Okay, that is sort of the guess vector we take, right? And after that we calculate x based on that, and this B has to be a unit vector. Okay, so in our case it is a 4 cross 4 matrix, so we will choose a vector like this 1 by 4, 1 by 4, 1 by 4 and 1 by 4. So this is based on that you have to get a unit vector. That is why we are making this choice. Okay, so for here Ax is equal to B. Now B is 1 by 4 1 by 4, 1 by 4 and 1 by 4. Okay. So it implies x is what? A inverse into B. Now, since you have done this, then I have calculated, I will directly write what the value of x is. So x is coming out to be 186.2500. Correct me if I am wrong somewhere, because I have not watched that lecture. This, let me write.
No.
So x is coming out to be 186.
Minus 33.8125. Actually, this answer is second iteration answer.
Okay, yeah. And my submission also, sorry.
Yes.
I'm doing it.
Ah.
Yeah. So after the first iteration, like when we do it, x is equal to A inverse into B, and the value of x is coming out to be minus 33.8125. Okay. Then minus 46.0938, then 83.4844, and then minus 67.00. Okay.
Yes.
Now what do we need to calculate here? We will calculate the one norm of x. Okay. And then first calculating the one norm of x, we know this is here, this is transpose. Okay. So one norm is nothing but the sum of the absolute values of the columns. Okay, the maximum. So here we have only one column. So the sum of the absolute values of these entries is coming out to be 230.3906. I am going through this quickly because it has already been discussed. So this is the one norm of x. Now after this, what is the next step of the algorithm? That we calculate w. We all don't know that w is what? It is the sign of x, right? It's the vector containing the sign of x. So that means whatever the signs of the entries are there, we write we multiply that with 1 and write as the entries of the w. So here it's minus 33, so first entry will be minus 1. It's minus 46 point something, so it will be minus 1. Third one is a positive entry, so it will be 1, and last one will be minus 1. Correct? Now, after calculating this, the second step is that we calculate A transpose Y is equal to W, right? And again, it will be what? Y is equal to A transpose inverse into W. Okay. Now, obviously, this is also simple to calculate. We have to take the A transpose, then that's inverse and multiply it with W. So I will quickly tell what it is coming out to be. You can cross verify. So it's coming out to be 10 to the power 3 into 0.4023. The second entry is 0.7186. Third is minus 1.2688. And the last entry is 1.0695. Okay. This is transpose. Okay. Are these the correct values?
Yes, ma'am.
Okay. So after calculating this, we will calculate the infinity norm of y. Now what is the infinity norm of y? Here we take the maximum of the rows. Right? Row sum. But here we can see there is only one column. So in each row there is only one entry. So here third row is 1.26 into 10 to the power 3. That is the maximum. So it is coming out to be, it is coming out to be 1.2688 into 10 to the power 3. Okay, fine till here. And we got this value for j equal to what? 3. Right? You understand this. So now we have to compare this infinity norm with this one norm of x. Okay. Now here we can see that infinity norm of the y is coming out to be greater than the one norm of x, right? So we do not stop. We will continue to the next step. And we will redefine our guess because we had initially taken it as 1 by 4, 1 by 4. Now, since we are not getting the desired like answer, if it had been if y infinity norm of y would be less or equal to the one norm of x, we would stop and we would assume that this is the norm of a inverse. Okay, basically what the condition number is, and what we are trying to get through this algorithm is that we know that condition number is nothing but norm of one norm of a into one norm of a inverse, right?
Yes.
So, uh, so yeah. So one norm of A we can calculate easily, and for A inverse it becomes difficult. So we follow this procedure. Like if the given matrix is very like large. So right now y like infinity norm of y is coming out to be greater than the one norm of x. So we proceed to the next step and we redefine this b. So therefore b is what? We say b is and like, okay, let me write it here. We say b is the ej vector. Ej means that the j equal to 3, what we have gotten here, that entry is going to be 1 and rest are going to be 0. So it is e3 here, so it will be 0, 0, 1 and 0. Okay. Now after doing this, we will again follow the same procedure. Okay, and here when we calculate again, okay, again calculating ax is equal to b, it implies x is equal to a inverse b, and now here we have to substitute the new value of b. Okay, so x is coming out to be so here x is coming out to be 186.2500, 253.8750, minus 459.6875, and the fourth entry is 369.00. Okay, transpose. Now here again we will follow the same procedure. We will calculate the one norm of x, and that would be what? Summing all the entries of the column. So the absolute values of the column. So that is coming out to be 1.268 into 10 to the power 3. Okay. Now again forming the sign vector, it will be what? This entry is positive, so it will be 1. This is positive, so 1. The third one is negative, so minus 1. The fourth one is positive, so 1. Okay. This is the sign matrix. Again we will do what? A transpose y is equal to w. And here we will find the value of y, which is A transpose inverse into w. And this thing, when you calculate, it is coming out to be minus 0.4023, minus 0.7186, 1.2688, and minus 1.0695. Okay. Now here when we calculate the infinity norm of y, it is coming out to be, see, the third one is maximum, so it will be 1.2688. Sorry, here it is into 10 to the power 3. Okay, when you calculate it, you get it like that. So this, now you can see that it's coming out to be same as this. Okay, so here we see that the infinity norm of y is equal to the one norm of x, and we stop. And we say that the one norm of A inverse is equal to the one norm of this x, which is equal to 1.2688 into 10 to the power 3. Now since we have calculated this and we need the condition number, we simply know that condition number is one norm of A into one norm of A inverse. Okay, so one norm of A is nothing, we can simply like calculate it from here. You can see the maximum entries are clearly from the third column. So 8 plus 10 plus 20 plus 14, it is coming out to be 52. So 52 will be the one norm of A, and the one norm of A inverse is 1.2688 into 10 to the power 3. So it is coming out to be 65977.6. So you can see that this K is a very large number. So from here we can say that A is ill conditioned, right? So you have already done a lot of questions on conditioning of matrices, etc. And you can see that the condition number is very huge. So this is an ill conditioned matrix. Okay, fine till here. Should we move to the next question?
Yes.
Okay. Hmm. Okay. Hmm. So the third question is that we are given a matrix, okay, that is equal to 2, 1, 1, 2. Okay. And the S matrix is given as 3, 0, 0, 1. Okay. Now we have to basically calculate U matrix. Okay. So how do we do this question? Anyone? There might have been similar questions in your assignment. So if anyone has done it,
Yes.
okay.
Yes. Using singular value decomposition. Uh,
Yeah.
uh,
So
for finding B, use the A transpose in A. So their eigenvalue, then corresponding eigenvectors
yeah.
form.
Hmm.
For U, two ways you can do. One, A transpose.
Hmm.
Eigenvalues and corresponding eigenvectors of A transpose gives U matrix.
That will give you V matrix. Like first you calculate a V
Uh,
only, no, like that. So, that is the
A transpose A gives B,
yeah.
but
Okay,
A
okay.
into
Your
A
A
transpose
into
U.
yeah. Okay, A into A gives.
That is another remark, is it?
Yeah.
Or else another way
Another way
after
is
finding
simply we can after finding
uh,
V transpose, we can write A
V.
is equal to U sigma V transpose, right?
Uh, yes, ma'am.
Okay, so since that is the standard procedure, I am going to follow that. If in the other way your answer is coming out to be correct, that is also fine. Okay, so let's go through the solution. You can try this along with me.
Okay,
Now,
ma'am.
huh?
Okay, okay.
Okay, okay,
I said okay, ma'am.
okay. So we know that any matrix A, okay, by any I mean it does not have to be symmetric, real, or anything. So like any matrix can be written in the form of U sigma V transpose, where U and V are two orthogonal matrices. And what is this sigma? This sigma is a diagonal matrix which contains its entries as sigma 1 and sigma 2, which are nothing but singular values of A, which we talked earlier in the question 1. I told you to find out the singular values of A, right? And those singular values are nothing but the eigenvalues of A transpose A. We have discussed this in previous classes also, right? So any matrix A can be decomposed like this. So this is known as SVD. Okay, singular value decomposition. So now following this procedure, here A is given already, sigma is given. Now sigma is given as 3001. What does it signify? That it is equal to nothing but sigma 1, 0, 0 and sigma 2. Correct? Sigma 1 and sigma 2 are these singular values. So sigma 1 is equal to 3 and sigma 2 is equal to 1. Right? Now, what is A transpose A? Can you tell me quickly? Quickly calculate and tell me what A transpose A is coming out to be.
5445.
Okay, so you have done it already?
Yes.
Okay, so there is the same question in assignment also.
Yes.
Oh.
It's an assignment question.
Yeah, these I think then they are repeated, like many questions are repeated in previous year assignments. Okay, it's fine if you have done it. If not, then you can do it. So see, you can see A transpose and A are the same, and it is coming out to be 5445.
4, 5.
Okay. Now, the eigenvalues of A transpose A are what? Sigma 1 square and sigma 2 square. Okay.
2 square.
And corresponding to these eigenvalues, we can calculate eigenvectors, right? You have done those in initial classes also. So we can say that for like, okay, we can say that A transpose A into V1, okay, is equal to sigma 1 square into V1. You know how I wrote this? Eigenvalues are basically what? We write that A lambda is equal to lambda into V, right? Then we write A minus lambda into V is equal to 0. So those are basically eigenvalues. And these so eigenvalues are basically that when multiplied with the eigenvector, or when this matrix A transpose A operates on its eigenvectors, it gives its eigenvalue into that eigenvector. So there is no change but just a magnification. What we can say that scalar elongation of that vector is happening there. No rotation or any other change is happening to that vector. Basically, that is the concept of eigenvectors and eigenvalues. So from here we can find that A transpose A is what? 5, 4, 4 and 5. Okay. And V1 we can write, say, I have taken alpha beta. Okay. Now sigma 1 square is what? 9. Okay. And it can be written as alpha and beta. So from here we will get two equations in alpha and beta and we'll have to solve that. So here it is 5 alpha plus 4 beta is equal to 9 alpha, which implies 4 alpha is equal to 4 beta, implying alpha is equal to beta. Okay. And the second equation is 4 alpha plus 5 beta is equal to 9 beta. Okay. It will again give the same result, that alpha is equal to beta. So what is our first eigenvector? It is alpha into beta, which we can write as alpha times like alpha into alpha. It can be written as alpha into 1. Okay. And we can put alpha anything. I will choose alpha equal to 1. Okay. There is nothing new in this. You have done these things already. Okay. Now choosing alpha equal to 1, we get our first vector, which is the V1 vector. Okay. But you know that when we calculate this V, it is going to be an orthogonal matrix. So What is the property of orthogonal matrix? We know that in any orthogonal matrix, every column of that matrix is a unit vector. So we have to make sure that it is a unit vector. So to make it a unit vector, we will divide it by its magnitude, and it will be equal to 1 by root 2 and 1 by root 2, correct?
Yes.
So this will be our V1 vector. Okay. Now for sigma equal to 1, implying sigma square is equal to what? That is also equal to 1, and that is our lambda 2, correct? For this we will calculate in the same procedure we will calculate A transpose A into V2 is equal to sigma 2 square into V2. Here we can choose, like A transpose A we have already calculated as 5, 4, 4 and 5, and V2 we will calculate, we can put it as gamma and say gamma and delta we can call it as, okay, and it will be 1 into gamma and delta. Can you quickly tell me what are the expressions for gamma and delta? Like what is the V2 vector coming out to be? Kavita, you have done it fine. What about others? Ravi and Revati, have you done these questions? Okay, you have not done. So do it right now. Do it right now. Just in the first way, like in the similar way as we calculated the first eigenvector, do it for this one and tell me what the second vector is coming out to be. One comma minus one. Yeah.
Yes.
Okay. ठीक है. I have
Then
chosen.
normalized.
Yeah, you have to normalize it. Tell me what is the orthogonal.
1 by root 2 minus 1 by root 2.
Yeah. So okay, you can get it that way because you might have chosen delta equal to minus 1. I have chosen it differently and I am getting minus 1 and 1. So that is not a big deal. Okay.
Okay.
So I have taken it as 5 gamma plus 4 delta is equal to gamma, and 4 gamma plus 5 delta is equal to delta. From these two equations, I am getting gamma equal to minus delta. Okay. That is the expression you will get. Therefore, V2 will be what? Gamma into delta, right? So gamma I can take out and it will be minus 1 into 1. Okay. Right. Gamma is minus delta. So I'll put minus delta here. Sorry, delta will come out. Okay. So delta will come out and it will be minus 1 and 1. So here I have chosen delta equal to 1. You might have taken delta equal to minus 1 to make it 1 and minus 1. So my answer is coming out to be minus 1 comma 1. Okay. So therefore my V2 vector will be V2 upon magnitude of V2, which is coming out to be minus 1 by root 2 and 1 by root 2. So with this we have calculated our V matrix, right? Therefore we can say V is what? V1 and V2. Okay. So this thing will be, what was our V1? 1 by root 2 and 1 by root 2. And our V2 vector is minus 1 by root 2 and 1 by root 2. Okay. So V we have calculated. Now to find U, okay, belonging to R 2 cross 2, okay, because A is also a 2 cross 2 matrix. So, as Kavita said, here we have two ways. Either we can write it as A into A transpose, or using the standard procedure, we can simply say that since A is equal to U sigma V transpose, correct? It implies A into, can we post multiply this equation by V? We can clearly do that, right? So we'll post multiply it with V, it will be AV is equal to U sigma V transpose into V. Now this V transpose V, since this is an orthogonal matrix V, so it will be I. V transpose into V will be identity matrix. So it can be written as A into V is equal to U into sigma. Now you have already, okay, U we have to calculate, sorry. So let us suppose, okay, A we have 2, 1, 1 and 2. V we have calculated as 1 by root 2, 1 by root 2 minus 1 by root 2 and 1 by root 2, right? This we have calculated. Now from here we can see that U is also going to be a 2 cross 2 matrix. So let we say that entries are A, B, C and D, okay? And here sigma is already given in the question, that is equal to 3, 0, 0 and 1, okay? So multiplying on left hand side, what are we getting? It is 2 by root 2 minus 1 by root 2, it will be, no wait a second, 2 by root 2 plus 1 by root 2, it will be 3 by root 2 minus 2 by root 2 and 1 by root 2, it will be 1 by root 2, sorry, minus 1 by root 2.
Minus.
Then 1 by root 2 plus 1 by root 2, it will be 2 by root 2. And the last one will be 1 by root 2, okay? Minus 1 by root 2 and plus 2 by 1 by root 2. And
3 by root 2.
3, no, in your case.
Second row. Second row, first entry.
Sorry. Yeah, this one will be 1 by root 2 plus 2 by root 2, it will be 3 by root 2. It will be 3 by root 2. Okay? Now on the right hand side it will be 3A, okay? Then B, then it will be 3C and then it will be D, correct? Now we can simply compare. So from here A is coming out to be 3, sorry, no, A is coming out to be 1 by root 2. Okay? You can simply compare the entries. B is coming out to be minus 1 by root 2. C is coming out to be 1 by root 2. And D is coming out to be 1 by root 2. Therefore, our U matrix is going to be 1 by root 2, minus 1 by root 2, 1 by root 2 and 1 by root 2. Since you have taken a different value here for the second row, this might be slightly different, but that you will from seeing the options you can choose the correct one if it is an MCQ based question. And yeah, Kavita, for your query, I had inquired the NAPTEL team. So they said that mostly the exam pattern is the same as assignment pattern, like 90% of the time, 95% of the time, it is the same pattern followed as in the assignments. And however, it depends on the course instructor. So it might change also, like it completely depends on the course instructor whether the exam will be online or offline, what will be the pattern. But most of the times every instructor follows the same pattern, like they have given assignments, in that pattern only the exam will be there. And still you can ask this in discussion forum because you'll already be added there now. This thing you can ask there once, that what will be the pattern of the exam, because these are general queries, they will answer you there. Okay. So everyone got till here? Those who are not solved at home, are you able to solve it here? We can multiply sigma with minus 1. It's your choice. Like what sigma with minus 1? I'm not getting it. Sigma with sigma inverse. No, see, that is not the purpose here. Most of the time, sigma is not going to be like square matrix, and you cannot find the inverse of the rectangular matrix, right? That is the purpose of SVD. Because A here it is in this question it is given a 2 cross 2 matrix, but A might not be a square matrix. Sometimes A can be any matrix, m cross n matrix, can be a rectangular matrix, and the order of the A matrix is the same as the order of sigma. If it is A is m cross n, sigma is also m cross n. So we cannot do it that way because sigma will not, like, we cannot find the inverse of sigma. Okay. So now, if you have done till here, can we move to the next question? So the next question is, let A is equal to USV transpose be the singular value decomposition where A is equal to, it is a rectangular matrix, okay, and S is equal to 7.3485 0 0 0 0 and 0. Okay, then find U transpose A transpose A into U. Okay, so we have been given a matrix. Here you can see it is a 3 cross 2 matrix, right? And the sigma is also given, and we have to calculate. Basically, this is an objective type question, multiple choice question, and there were 4 options, but the left hand side was the same. It was U transpose into A transpose A into U. So we have to find this. Okay, so how do we calculate it? Any guesses? How do we calculate this? Okay, we know that U transpose A, okay, sorry, it's not A transpose A, it is A into A transpose, yeah. Okay, so we know that U transpose A into V can be written as sigma, or here it is given as S, right? Let me replace it with S. Okay, I have done nothing, but I have taken this expression only. Okay, let me do it from there only. Okay, so we have been given that A is equal to U into S into V transpose. Then we can post multiply it with U transpose, right? So we can write U transpose A is equal to U transpose U into S into V transpose, correct? And it will be U transpose A into U transpose U will be what? Identity matrix, so it will be S into V transpose. Now to eliminate this V transpose on right hand side, we will post multiply with V. So we can write U transpose A into V is equal to S into V transpose into V. Now this V transpose and V will again go, so it will be U transpose A into V is equal to S. Correct?
Hmm.
Now if we take the transpose of this whole thing, okay, say S, now S we have found out to be U transpose A into V, and we take S transpose. What will S transpose will be equal to U transpose A into V ka whole transpose, right? It will be what? V
V
transpose
trans
A
V
transpose
transpose
and U.
U.
Correct. Now if you see here what we have given in the question, U transpose A into A transpose and U. So our U transpose should be first. So we can multiply S with S transpose. Okay. So multiplying S with S transpose will give us what? U transpose A into V multiplied with V transpose A transpose U. Correct. So it will be U transpose A into what will be V into V transpose? It will be identity matrix. So we don't need to write it. And here it will be A transpose and U. So is this the expression we are asked in question? Right. So this is coming
Yes.
out to be S into S transpose. So tell me quickly what you are getting the value of S into S transpose. Given that S is equal to 7.8, sorry,
3485.
7.34850000 into S transpose will be what? 7.3485000000. Okay. Tell me what you are getting this value as.
54.00045.
Okay. So you are getting this. This will be a 3 cross 3 matrix. So it will be 54 0 0 0 0 0 0 0 0. Okay. So the answer
Yes.
is, it is a diagonal matrix. Okay. It will be written as diag. This is just a notation of this thing only. Okay. Like this thing here is a notation of this thing. Okay. Understood everyone till here? So let's move to the next question. Okay. This one is a bit lengthy. Okay. But this is also there in the previous year assignment. So yeah. So the question is, let A is equal to USV transpose be a singular value decomposition. Okay. Where U where you and we are 4 cross 4 and 3 cross 3 real orthogonal matrices respectively, and let A, let me write it here, let let A is equal to, so the A is given as 4 cross 3 matrix 2 0 0 0 2 1 0 1 2 and 0 0 0. Okay, then we have to calculate the values of V and U. Okay, so this is a bit lengthy, but since it is given an assignment, so you can expect that something of this order can come in exams also. And I would suggest you people to not use MATLAB in these questions, because see, MATLAB makes this very simple, like the calculations very simple. But when you are performing those calculations in exam and you do not have a practice of doing it at home, like the matrix multiplication and all, you are going to make silly mistakes, and that will like end up in ruining your whole like question. Even small mistakes can do that. So whenever you're trying these assignments, even if there are long questions, please try to do it with the help of calculator only. Don't use MATLAB, because like MATLAB makes it very simple for finding A, then A transpose and multiplication. So that is not the purpose. Okay, so first step here will be again what, that we will first calculate.
V,
See,
V.
here see, in the previous question sigma was given, but here we will first calculate sigma matrix, right? So how do we find sigma? Anyone? How will we find sigma?
First find V, that is A transpose A, eigenvalues of A transpose A.
Yeah, correct. We know that sigma is nothing but what? A matrix which contains the singular values of A, right, as its diagonal entries. And singular values of A are nothing but, again I am telling, that eigenvectors or eigenvalues of A transpose A. So first we will find A transpose A. So everyone quickly do it. Tell me what is A transpose A coming out to be.
400
Okay, 400.
054
Okay.
045.
So how did you calculate it so fast? Don't tell me this is also repeated.
Manually. Manually I did A transpose A only.
Okay, fine. So okay, everyone, I hope everyone has done it. Now calculate the lambdas for this thing. How will you do that? You'll have to follow the normal procedure, that determinant of 4 minus lambda 0 0 and then 0 5 minus lambda 4, then 0 4 and 5 minus lambda is equal to 0. Okay, so that is 4 minus lambda 0 0. Tell me what you are getting the values of lambda. Quickly do it. It will be 4 minus lambda into 5 minus lambda square, okay, minus 16, and rest 2 will be 0. It will be 4 minus lambda into a square plus b square minus 2ab. 4 minus lambda into lambda square minus 10 lambda, and it will be plus 9, right? It will be 4 minus lambda into lambda will be 9 into 1, okay? I'm getting, okay, yeah. Lambda minus 1 into lambda minus 9 is equal to 0. So clearly here we can see it is coming out to be lambda is equal to 1, 9, and lambda is equal to 4. Calculate it till here. Okay, what about others?
Yes, ma'am. Calculator.
Okay, now find the corresponding vectors, corresponding eigenvectors.
Eigenvectors.
Yeah, tell me what is the value of v1, v2, and v3, and don't forget to normalize it.
For lambda equal to 1, eigenvector is 0, 1, minus 1.
0, 1, minus 1, corresponding to 1.
Yes.
Yeah, okay. You have to normalize it. That is correct. Then it will be
normalize.
minus 1 by root 2 and 1 by root 2. Okay. So it is coming to be 0,
0,
minus 1 by root 2 and 1 by root 2.
1 by root 2.
Okay. What about others? Others are calculated it. Now you can do that for V2. For lambda equal to say 4. Okay. We'll go in ascending order. Did not get it. You might have made some error because this is the like correct answer. So you can check your calculation once more. This is, you will get it corresponding to lambda equal to 1. Okay. But you can still try during the class, check it for lambda equal to 4. You can again do it.
Zero minus,
Sorry.
for lambda is equal to 4, eigenvector 0 minus 4, 1.
No,
No.
I think that is incorrect. You can check your calculations again maybe.
Okay.
Okay, take a minute and try to make it right. What about you, Revetha? You're getting answers?
For lambda equal to 9, it is 0, 1, 1.
Yeah, and that is again equal to 0, 1 by 2, 1 by 2, 1 by 2,
Right.
1 by 2. Okay. This one is correct. For lambda equal to 4, you are correct calculating incorrectly. So that will be equal to 1, 0 and 0. Okay. You will get it something like this. Okay. So now since we have gotten our lambdas and this eigenvectors, okay, eigenvalues and eigenvectors, we can simply form the sigma and the V. So what is sigma? Sigma is basically we are arranging the eigenvalues in decreasing order. Okay, so here it will be under root of 9. Okay,
Oh.
0, 0. Then it will be 0 under root of 4, 0. Then it will be 0, 0 under root of 1 and 0, 0 and 0. Okay, so your sigma will be 3, 0, 0, 0, 2, 0, 0, 0, 1 and 0, 0, 0. Okay, this will be your sigma. Now for V, we know that, see here there is a like not trick but a catch, that you have to write the V1, the eigenvectors not corresponding to how you found it but corresponding to these entries in sigma. See here it is 3, so you will write the like the first eigenvector corresponding to lambda equal to 9. Then it is 4 here, no? Then your second eigenvector should be V2 and third vector should be V1. Okay, like third vector should be 1. Okay, so that you'll take care of. So it will be 0, 1 by root 2 and 1 by root 2. Now corresponding to 2 we have 1, 0, 0. So the second vector will be 1, 0, 0. And the third is 1. So for corresponding to that, it will be 0, minus 1 by root 2 and 1 by root 2. Okay. 0, minus 1 by root 2 and 1 by root 2. Okay. Understood till here? Is everyone clear till here? Okay, last step. This V equal to this thing now. See, sigma, you know clearly how to find sigma. Okay, sigma, you have understood that sigma is basically the eigenvalues. Here there is written as sigma 1 square. Okay, so it will be the under root of your eigenvalue. So it will be under root 9, and it will be under root of 4, and it will be under root of 1. Okay, that you understood how we get it. After that, when we are writing V, we have to maintain the order. Okay, in sigma also we start from increasing. See, here we have to keep 9, here we have to keep 4, and here 1. You cannot put 1 here, 4 here, or sorry, under root 4, like under root 1 here or under root 4 here. You have to follow the descending order. The greater number will be here in the first column, like in the decreasing order you have to put that, and corresponding to that you have to put the eigenvectors. Like here it was 3, and the eigenvector corresponding to this 3 or this lambda equal to 9, you have to put that here. Then the eigenvector corresponding to this 4, which was this, okay, 1 0 0, here you can see this corresponding to the second column, you will put that, and for the third column it will be the lambda equal to 1, so the minimum value of lambda. Okay, this is the order you have to maintain. Understood? Okay, now after doing this comes the final step of this SVD. We know that we have A now, we have V now, we have sigma. Now what we have to find? U. So here we have A is equal to U sigma V transpose. Okay, now again we will post multiply it with V. So it will be A V is equal to U into sigma. Okay, now here when we multiply A with V, A is what? 2 0 0 0 2 1 0 1 2 and 0 0 0. Okay, this is our A matrix. Then our V matrix is 0 1 by root 2 1 by root 2. Okay, then 1 0 0, then 0 minus 1 by root 2 and 1 by root 2. Okay, this is basically our LHS. Okay, so calculate this and tell me what you are getting here. This multiplication. Do it quickly and tell me.
Zero to zero.
Wait a second, Kavita.
Okay.
Yeah, so 0 to 0. The second column, sorry, the second row.
3 by root 2.
Yeah, 3 by root 2,
0
0.
minus 1. Ma'am, it is 3 by root 2.
Okay, 3 by root 2. 3 by root 2. Wait, let me check it. Is it the same? 3. Yeah, 3 by root 2. Yeah, 0 and minus 1 by root 2. And the third is?
3 by root 2.
Yeah.
0. 1 by root 2.
And the last one will be 0 0 0. Okay. Now
Yes.
this is your LHS. Okay. Now we will form some equations on RHS and then we will compare it with these and find the U matrix. Now U taking RHS. Okay, this is a very lengthy question, but we have no other choice. You have to do it like this only. So U into sigma. So sigma was 3 0 0 0 2 0 0 0 1 and then it's 0 0 0. So on the LHS we are getting a 4 cross 3 matrix, right? And this here is 4 cross 3. So our U will be what? A 4 cross 4 matrix, right? Understood? 4 cross U has to be a 4 cross 4 matrix. So we will form a 4 cross 4 matrix, say U11, U12, U13, U14. The second row will be U21, U22, U23, U24. Then U31, U32, U33 and U34, and the last one will be U41, U42, U43 and U44. Okay. And this will be 3 0 0 0 2 0 0 0 1 and 0 0 0. Okay. So this is coming out to be 3U11, 2U12. Please correct me if I am doing a mistake anywhere. It will be U13. Okay. That will be 3 times U21, twice U22. You can do it on your own and then we can cross check. It will be U23. The third row will be 3 times U31, twice U32 and U33. And the fourth one will be 3 times U41, twice U42 and U43. Okay. Everyone got this? Are you guys getting the same?
Yes.
Okay. Now what will we do? We will compare the both sides. Okay.
Hmm.
On comparing both the sides, we will get certain equations. See, 3 times U11 will be equal to what? 0.
0.
It implies U11 is equal to 0. Twice U12 is equal to 2. It implies U12 is equal to 1.
1.
Then U13 is equal to 0. Okay.
0.
Are you following me?
Yes, ma'am.
Now 3 times U21 will it be equal to what? 3 by root 2. Okay. So U21 will be what? 1 by root 2. Okay. And after that there is 3 times U31 is equal to again 3 by root 2, which implies U31 is equal to 1 by root 2. You have to do nothing, just you have to compare the entries of this matrix which we got on the right hand side. Okay, this matrix entries you have to compare with this matrix. Okay, so after that there is U41. 3 times U41 is coming out to be 0, which implies U41 is equal to 0. And U22 is equal to 0, U32 is equal to 0, okay, U42 is equal to 0, you can simply say it. Then U23 is equal to minus 1 by root 2 and U33 is equal to 1 by root 2 and U43 is equal to 0. Okay. Now, what are we missing here? Which entries we have not gotten yet? Hmm? See, U24 we have not gotten, okay. U24 we have not gotten. U3 4 we have not gotten, okay. U14 we have not gotten. And U44
Fourth
we have
column.
not gotten.
Fourth
Yeah.
column fully missing.
Fourth column fully we have not gotten, actually, yes. Because see, for in this RHS, what happened? The fourth column was like multiplied, it was multiplied with zeros and all the entries were gone. So fourth column we have not gotten at all. Okay. So how do we find the fourth column? The fourth column is entirely gone. So see, U we can express simply as U1, U2, U3 and U4, okay, where these are the column vectors. Now U1, U2 and U3 we have completely calculated. So what about U4? Okay, we can write U1 as, from our calculation, it's 0, 1 by root 2, 1 by root 2 and 0, okay. Then U2, as I have calculated, okay, it will be U12, U22, U32 and U42, correct? What is U12? Tell me fast, what is U12? I have to write it down here, I'll have to put it in
1.
the, okay. So U12 we got 1, right? U22,
0.
U22 we calculated as 0, U3 we 32
0.
calculated as 0 and U42 we calculated as 0, correct? What about U3?
Yes.
U3 will be written as U13, U23, U33 and U43, right? So it will be what? U13 is what?
0.
Okay, U13 is 0, U23 is?
Minus 1 by root 2.
Yeah, U33 is 1 by root 2 and U43 is 0, I
0.
guess. Yeah. So now we know that U4 is going to be U14, U24, U34 and U44. Now this is missing. Now here we can simply uh, apply one thing. We know that U is an orthogonal matrix, right? So in any orthogonal matrix, the every column vector is a unit matrix. So one equation we get from there, that this U vector, it should be unit vector. So we can take the magnitude U14 square plus U24 square plus U34 square plus U44 square equal to 1. Okay, one equation we get from there. Now other three equations, where we will get from? Anyone? We have done it before. We have done it many times. Kavita,
What, man?
where will we get the other three equations? Because we have four variables here. Now one equation we are getting from this, that this has to be a unit vector and it will be equal to, the magnitude will be equal to 1. Where we will get the other three vectors? Sorry, the other three equations.
Okay. So actually, first three columns form a range of A, and the fourth one is nullity of A transpose. So using this idea,
Okay,
we
we
can
can do
find
it
the
that
fourth.
way. So basically, you're telling that first three will be range space,
Oh,
and the third one will be
a
the
fourth one here.
null. Fourth, sorry, fourth will be null space of A transpose.
Null space of A transpose.
Yeah, yeah, we can do it that way. But since we are doing it this way, like
Hmm.
see, you can do it like this also. That we have done earlier also. That
Okay.
if U is an orthogonal matrix, the fourth column has to be a unit vector and its dot product with other three should be 0, right?
0.
That we have
Yes.
done. So we can do it that way also. I have done it that way. You can try in your own way and we can match the answers. Okay, so you
Not one way, ma'am. Just from the lectures, I just
yeah,
did
yeah,
this
I
method.
understood that there might be any theorem in the lecture also. So you can try that out. Okay, you can do it now, and I'll do it in my
Okay,
way,
ma'am.
and we can see if the answers are coming out exactly same. Okay.
Okay, ma'am.
So since I am writing, okay, my solution. Therefore, U is or okay, not therefore it will be because U is orthogonal. Okay, we must say that magnitude of U4 is equal to 1, which implies U14 square plus U24 square plus U34 square plus U44 square is equal to 1. Okay, this will be our first equation. And U1 transpose U4 is equal to 0. This will be our second equation. So when we multiply it, we'll get 1 by root 2 into U24 plus U34 is equal to 0, and from here we get U24 plus U34 is equal to 0, which will be our second equation. Now the third one is U2 transpose with U4 is equal to 0, which implies U14 plus 0 plus 0 plus 0 is equal to 0, which implies U14 is equal to 0. It will be our fourth equation. And the third is U3 transpose into U4 is equal to 0, which implies, okay, U3 transpose here. So it will be first entry 0, second entry second entry will be minus 1 by root 2, and here it will be U24 plus 1 by root 2 into U34, and the last is also 0. Okay, the first one is also 0. So it will be 0, and from here we get U24 is equal to U34. This is basically our fourth equation. This is third. So from 2 and 4, from equation 2 and equation 4, okay, see here equation 2 we have U24 is equal to U34, and here U24 is equal to U34. So we can say that twice U24 is equal to 0, okay, which implies U24 is equal to 0, which implies U34 is also equal to 0, because they are both same. We can simply just say that these two are equal to 0. Now for checking 0 square plus 0 square plus 1, okay, because third we are getting here as 1, and the fourth is U44 square. U44 square is equal to 1, because this is a unit vector. This equation, one equation I am following. So it implies U44 square is also equal to, I think, 0 or 1. No, sorry, this one is 0 here. U14 is 0, U24 is 0, U34 is 0, and U44 square we have to find. So this will be equal to 1. So our fourth vector is what? 0, 0, 0, 1. Okay. So therefore finally our U matrix will be what? U1, U2, U3 and U4. Which is equal to 0, 1 by root 2, 1 by root 2 and 0. The second column will be 1, 0, 0 and 0. The third column will be 0 minus 1 by root 2, 1 by root 2 and 0. And the fourth we just calculated 0, 0, 0 and 1. Okay, this is the U matrix. So everyone understood till here?
Yes, ma'am.
Okay. So did you try to do it that way, Kavita?
Ah, yes, same
Same you're
answer I
giving?
got.
Okay. So you can follow whatever like clicks you and whatever you find easy. So okay. I think we can do one more question. That will be enough. Everyone copied till here? Others? Okay. See, we have been given a matrix A equal to 5, 1, 1 and 5. Okay. And its singular value decomposition. Okay. US, sorry, US USV transpose is its singular value decomposition. Now given vector V as V1 and V2 such that V1 is equal to 1 by root 2 and 1 by root 2 and V2 is equal to minus 1 by root 2 and 1 by root 2. Okay. So basically the V vector has been, V matrix has been given. Okay. And then we have been given an arbitrary vector x equal to. Then we have to comment about QA equal to V1 into V1 transpose is the orthogonal projection onto what? With QA x equal to x. Okay. So, okay. So basically, okay. So you have read this in the properties already, right? That QA into QA equal to V into V transpose is a unique orthogonal projection onto the range space of what? Range space of A transpose, right? With QAX equal to
X.
X. Fine. I think the proof of this has been given in the lectures, I guess. So I'll not go through it because in this question there are few statements given. Okay. So the statements I will read out to you. I will not write it. It's given as that QA equal to V1 into V1 transpose is the unique orthogonal projection onto range space of A transpose, or onto the range of A, or to the null space of A transpose, or to the null space of A. So we know that the QA equal to V1 into V transpose is the unique orthogonal projection to the range space of A transpose. Okay. So this is the answer for it. Okay. Now moving to a next question. Okay, we'll do a simple question that we have been given an matrix A equal to 1, 2, 3, 4, 5, 6. Okay, and then x1 is given as x1 vector is given as 1, 2, 5. Okay, and x2 is given as 6 and 25. Now the first part is find the matrix QB, okay, such that QB is the unique orthogonal projection onto range space of A transpose with QB x1 equal to x1. Okay, so here it's like the first question there, Q matrix was not given. Here also you have to find this QB matrix. Okay, so so how will we do this? Please give me a moment. Meanwhile, you can try this question. Okay. Okay. So how will we do this question? Anyone? For A, what will be the singular value decomposition? U sigma V transpose. Can you find that out? U sigma and V for A. Am I audible?
Yes, ma'am, audible.
Okay, so uh, please find out the singular value decomposition for A. You have been given a A matrix, you can find U sigma and V transpose. Basically, you need to find the V transpose so that we can write QB as what? QB equal to V into V transpose. because a unique orthogonal projection of a matrix Q onto the range space of A transpose, that is unique and it is equal to V into V transpose. So for that you have to find V. So can you quickly find out what the value of V is coming out to be? Or you can try to calculate all three for it. Calculate U, calculate sigma, and calculate V transpose. Firstly, you have to calculate sigma. So tell me what are you getting? How will we find sigma? Nothing but the eigenvalues of A we have to find out. Okay. Sorry, the eigenvalues of A transpose A we have to find out. And those we have to put in the diagonal entries.
A
Calculate.
transpose A transpose E, it's a very big matrix.
Okay, A transpose A is coming out to be a big matrix. Okay, but it will be what? It is
17, 22, 27.
A transpose A.
20.
Okay, you're
Yes.
telling me A transpose A is coming out to be what?
17, 22, 27,
Uh huh.
22, 29, 36,
Okay.
27, 36,
37.
40, 27,
Uh huh.
36,
Uh,
45.
45. Okay. So, yeah, it is a big matrix. Like the entries are big. It's not a big matrix.
Okay.
Huh. So, but you have to find it anyway. You can take time here. In exams, there might be simpler questions, but I have taken this from assignment only. So, if whatever the level of assignments is there, you can expect that the level of exams will be more than that, right? If not equal, then more than that. There won't be simple questions than the assignment. So, it is a previous year assignment question. So, you can try to solve it. You just have to form the the cubic equation. After that, the eigenvalues can be calculated in the calculator itself. Cubic is solvable in calculator. So try to do it and tell me what are you getting as the eigenvalues. Okay, see, I have calculated it here. So it is coming out to be 9.5080, then 0, and 0.7729 and 0. Okay, this is the value for sigma. Now second we will calculate what? U. So nothing new you have to do as you calculated in the previous questions. Here also we calculate U in the same way. And V I have calculated first. So the value of V is coming out to be minus 0.4287, 0.8060, 0.4082. So here you can understand the procedure. If it's taking time, you can calculate it at home also, like for your practice purpose. So it's minus 0.5663. It will be 0.1124. It will be minus 0.8165. Okay. So it's minus 0.7039. I have used MATLAB to calculate these values. Otherwise, these are not like, it would be simple values like this minus 0.7039, it will be 1 over root 2. So this is minus 0.5812 and this one is 0.4082. Okay. Now what will be QB? QB will be V into V transpose. And when you find that out, okay, it is coming out to be a unitary matrix. I have done it. So you, for the cross verification, you can check, it will be like this only. And now from our question, we have to we have been given that this QB is the unique orthogonal projection with QB x1 equal to x1. Okay. So QB x1 is equal to 1 0 0 0 1 0 0 0 1 into x1 is equal to x1. Obviously this is a unitary matrix. In this case it's a unitary matrix. So and x1 is 1 2 5, it will come out to be x1. So this thing is correct. Okay. I mean this is the solution. You have to find QB only. Okay. Understood till here? I think this much is sufficient for today.
QB, QB is orthogonal projection of range of A transpose.
Yeah. But how do we find it? It is equal to